Yeah, what do you mean by significant figures means? The number of trustworthy digits, right? The number of trustworthy digits in a given value, that is nothing but significant figures. Are you clear? In any value, how many trustworthy numbers are there? Clear? In any value, how many trustworthy numbers are there? That can be explained with the help of significant figures. The best example, once again we'll discuss, for suppose the same example. So in NEET I got 360 plus marks. Clear? Let us take I got 360 plus marks. Okay, ఈ 360 plus marks lo 360 is confirm, but this last digit may vary. It may vary from 1 to 9. So this last digit can't be trustworthy, but first two digits can be trustworthy. So the number of trustworthy digits in the given data or value is nothing but significant figures. Then how to study the significant figures in physics means, for suppose if I take digits, in mathematics we have total 10 digits, right, starting from 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, all the non-zero digits are trustworthy. Are you clear? All the non-zero digits are what? Trustworthy, which means that we can reliable on that, we can depend on that, we can believe those numbers. Clear? So all non-zero numbers are significant. Significant means we have to count. Clear? All the non-zero numbers are what? Significant, which means that we can count. Then unsignificant or insignificant we are getting only because of 0. That 0 we can divide into 3 parts. In that first part is leading zeros. And yesterday we already discussed that all leading zeros are non-significant. So rules and regulations not required, just remember like that. You can easily understand this, okay? So leading zeros, all leading zeros are non-significant, whether it is with decimal or without decimal. Non-significant means you need not to count those numbers. Then next, all trapped zeros. Now please remember, all trapped zeros. Clear? All trapped zeros are significant, which means that we have to count those numbers. Then last one more thing is that trailing zeros. Clear? Trailing zeros. So all trailing zeros, we have the two conditions. In that first condition is with decimal. Clear? With decimal. And second condition is without decimal. Clear? Second condition is without decimal. All trailing zeros with decimal are significant. Significant means we have to count. All trailing zeros without decimal are non-significant. Non-significant means need not to count. Are you clear? So this is the significant figure chart. Are you clear up to here? But there is one more concept called as the scientific notation. In scientific notation, any number can be written as a into 10 to the power of b, where b may be of any number. It may be a positive value or it may be a negative value also. Clear? Always we have to measure or take the significant figures for a only. The best example, if I write 3 into 10 to the power of 8, 3 into 10 to the power of 8, it looks like a into 10 to the power of b, right? So then how many significant figures are there here? 1. Do you understand this? For suppose I will write like this, 6.625 into 10 to the power of minus 34. You cannot take this. We have to take only this value, a value. Now how many significant figures are there? Means 1, 2, 3, 4. Because these 4 are non-zero. Non-zero are always significant. Are you clear? Okay, now I'll give you some examples. You just try to tell me the answer. How many significant figures are there in each number? Okay. Example 2, 3, 4, 5. 4 significant figures, because all 4 are non-zero digits. So how many significant figures are there? 4. Means all 4 values or numbers we have to consider. So yeah, next example 2, 3, 4, 5, 0. 4 significant figures. First look at the 0 position. 0 is trailing or leading or lagging. Sorry, trailing or trapping or leading. Trailing. Trailing zeros, this is decimal or without decimal? Without decimal. Trailing zeros without decimal are non-significant, which means that you can't count it. Okay, na? So this is the trailing zero. This is without decimal. So therefore need not to take this 0. Cut down that 0. So how many significant figures are there? 4. For suppose I will take like this 2, 3, 4, 5.00. 6. Because these two are which zeros? Trailing zeros. Trailing zeros with decimal are significant. So total how many significant numbers are there? 6. For suppose I'll write like this 234050. 5. Because here two zeros are there. One zero is trapped. This is trapped 0. And this is which 0? Trailing 0. Decimal unda leda? No decimal. No decimal means not significant. So cut down this number. So total how many numbers are there? 5. Now for suppose if I write like 00234. 3. Why? Because these two zeros are leading zeros. My leading zeros are non-significant. Adani ippudu chadivindi. So leading zeros are non-significant. Are you clear? Always remember leading zeros are non-significant. So then how many numbers are there? Significant numbers 3. Only 3 significant numbers are there. For suppose I'll write like this 0.2340. 4. ఎందుకమ్మా ఇది లీడింగ్ జీరో. లీడింగ్ జీరో ఎప్పుడు కన్సిడర్ చేసుకోకూడదు. దిస్ ఈజ్ విచ్ జీరో? ట్రైలింగ్ జీరో. విత్ డెసిమల్ ఆర్ వితౌట్ డెసిమల్? సో ట్రైలింగ్ జీరో విత్ డెసిమల్ is significant. We have to count. So this 0 we have to count. Then what is the answer? 4. For suppose I'll take like this 0.203040. 6. Is it trailing 0 or leading 0? Leading 0 is always not significant. This is trapped zeros. Trapped zeros are significant. And this is trailing 0. With decimal or without decimal? So it is also significant. So total this numbers is 6. Are you clear up to here? Then next we are going to study about the rounding of digits. No, rounding of digits. Significant figures is easy topic only. In scientific notation you understood, right? 10 power anything is there. We didn't consider the 10 power as a significant figures. Front what is the value is there, that only we have to consider. For suppose we have the 9.1 into 10 to the power of minus 31 kg. Okay, so 9.1 into 10 to the power of 31 minus 31 kg. But ikkada 10 to the power of minus 31 we cannot take, need not to take. So idena manam teesukovalsindi. Ikkada any significant figures unnayamo? 2. Are you clear? Or else 6.625 into 10 to the power of minus 34. 4 significant figures. 3 into 10 to the power of 8. 1. Shall I write like this? For suppose 300 into 10 to the power of 6 and rastani ide. Then how many significant figures are there? 3 into 10 to the power of 8, right? This only I'll write 300 into 10 to the power of 6. Now how many significant figures are there? 1 only. Because these two zeros are trailing zeros. With decimal or without decimal? Without decimal. Are you clear? So therefore we cannot count those. Are you clear up to here? Do you understand up to here? Fine. Then the next topic is rounding of digits. Now for suppose we have some value like this. I'll take the value like 1, 2, 3, 4, some x and y I will take. Are you clear? ఒక వాల్యూ ఉంది, వాల్యూలో లాస్ట్ 2 digits ఉన్నాయి కదా, లాస్ట్ 2 digitsని I'll take x and y. Okay, this x is called as a preceding number. What is x called as? Preceding number. And this y is nothing but last digit. Are you clear? This y is nothing but what? Last digit. My x is preceding number and y is nothing but last digit. Now rounding of digits depends on the last digit. Clear? Rounding of digits depends on last digit. If the last digit is greater than 5, are you clear? If the last digit is greater than 5, so for suppose if I take it as a last digit, so I'll take y as last digit and x as a preceding number. Yeah, so this is preceding number. Okay, this is preceding number and y is last digit. Clear? And y is what? My last digit. For suppose if I take last digit y, clear? If I take last digit y, it is greater than 5, if it is greater than 5, clear, if last digit is greater than 5, then preceding number we have to add plus 1. Okay, then preceding number plus 1. So we have to add plus 1 to the preceding number. Clear, we have to add plus 1 to the preceding number. Okay, for example, I'll take one example like this. 1.2348 or else 1.2368 I will take. No, 1.2368. Then last digit is there at last digit is 8. 8 is greater than 5. Then cut down the last digit. Previous digit plus number 1 plus 1. So then what is this value? 1.237 is the answer. Okay. Now you can do further, like 7 digit also you can take greater than 5 and you can do further. But it depends on how many significant figures they asked. That we'll understand while doing the problems. Then for suppose if last digit is less than 5. Now if last digit is less than 5, then preceding digit no change. Clear? Preceding number no change. Clear? So preceding number no change. There is no change in the preceding number. For example, I'll take the number like this 1.2364. Now last digit is 4, right? 4 is less than 5. Less than 5 means you have to cut down the last digit. Previous number no change. Then what is the answer? 1.236. Then if last digit is equal to 5, then we'll get two different conditions, right? Now if last digit is equal to 5, then we'll get two conditions. In the two conditions are, if preceding number is even, right? If preceding number is even, now if preceding number is even, then there is no change. Okay, if preceding number is even, so this preceding number is there, right? If the preceding number is even, then there is no change in the preceding number. And if preceding number is odd, now if preceding number is odd, we have to add plus 1 to the preceding number. Now if preceding number is odd, we have to add plus 1 to the preceding number. Now see, for suppose if I take one example, okay, if I take one example, let us take the example like this. So I'll take one example. 1.2365 I will take. Now last digit is what? Last digit is 5, equal to 5. Preceding number is even or odd? Even. So even number means preceding number no change. Then cut down the last digit, then answer is 1.236. Okay. For suppose I will give you one more example. Example 1.23, let us take 35. Are you clear? Then last digit is equal to 5 and preceding number is odd. If last digit equal to 5 and preceding number is odd, then preceding number plus 1. So cut down the last digit, 1.234 is the answer. Are you clear? Just understand the rounding of digits. If you're done with this, I'll go for the next topic. Copy it. Parallel. I guess up to second chapter it is okay for you. Is it done? Then we are using significant figures in calculation part. Clear? Now please remember, in significant figures in calculation, in addition or subtraction. Now please remember, in addition or subtraction, please remember, means addition or subtraction, please try to understand, after adding all the data, the final answer should be round off till, now the final answer should be round off till the least decimal digits in the given data. Are you clear? till least decimal digits in the given data. For suppose I will give you one example. 1.1112 I will give, 0.11 I will take 1.234 and 0.9. Now add all the numbers and tell me what is the value. 3.3552, right? Now see, in the given data, who is having the least decimals? 0.9. How many decimal digits are there here? One decimal digit is there. Are you clear? In the given data, which is having the least decimal digits means 0.9. So only one decimal digit. So the final answer will be adjusted. The final answer will be adjusted till we will get the least decimal digits in the given data. అంటే ఇప్పుడు ఈ ఫైనల్ రిజల్ట్ ఉంది కదా, ఈ రిజల్ట్ని తీసుకోండి అమ్మ. ఈ రిజల్ట్లో లాస్ట్ నెంబర్ ఉంది కదా, దిస్ లాస్ట్ నెంబర్ ఇస్ లెస్ దాన్ 5. ఆర్ యూ క్లియర్? ఇఫ్ లాస్ట్ నెంబర్ ఇస్ లెస్ దాన్ 5, కట్ డౌన్ ద లాస్ట్ డిజిట్, ప్రీవియస్ నెంబర్ నో చేంజ్. అంటే ఇప్పుడు ఆన్సర్ ఎంత అవుతుంది? 3.355. కానీ మనం ఎన్ని డెసిమల్ డిజిట్స్ వరకు రెడ్యూస్ చేయాలి? 1 డెసిమల్ డిజిట్. సో అగైన్ టేక్ ద లాస్ట్ డిజిట్. లాస్ట్ డిజిట్ ఈజ్ ఈక్వల్ టు 5. Okay, last digit equal to 5. Equal to 5, we have two conditions. Linear, odd and even. So preceding number is even or odd? Odd. So odd means what we have to do means cut down the last digit. Previous number plus 1. So 3.36. Are you clear? Again, how many decimal digits we have? 2 decimal digits. We have to reduce up to 1 decimal digit. Are you clear? So therefore last digit again you take. This last digit is greater than 5. My last digit is greater than 5. So which means that cut down the last digit, previous number plus 1. So the answer will be 3.4. Are you clear? Now shall I give one more example? One more example? Yeah, fine. I'll take 9.80 minus 0.0991. But today for study hour, you all people just gather in that room. Along with that intermediate students you sit, but you sit in front benches for the study hours. ఎంత వచ్చిందమ్మా ఆన్సర్? వాట్ ఈస్ ద ఆన్సర్ యూ గాట్? Yeah, here you can take 0, borrow it. Then what is this value? 10. 10 minus 9, sorry, 10 minus 1, 9. So here it is 9. Then 9 minus 9, 0. Are you clear? Again here 9 minus 9, 0. And this will become how much? 7.9. Are you clear? So this is the final answer I guess you got. But if you see the first data, in the first data how many least decimal digits are there? 2. This 0 also we have to count, right? Why we have to count this 0? Trailing 0 with decimal. Correct? Trailing 0 with decimal. We have to count even that also. Here how many decimals are there? 4 decimal digits. Are you clear? Here how many decimal digits are there? 4 decimal digits. So final answer will be adjusted till 2 decimal digits. అప్పుడు ఏమవుతుందంటే లాస్ట్ డిజిట్ ఈస్ గ్రేటర్ దాన్ 5, రైట్? ఇఫ్ లాస్ట్ డిజిట్ ఈస్ గ్రేటర్ దాన్ 5, కట్ డౌన్ ద లాస్ట్ డిజిట్. Yeah, previous number plus 1. So 9.701. then last digit is there, right? Last digit is less than 5. Last digit is less than 5 means previous number no change, so cut down the last digit, then previous number is 9.70. Are you clear? Now what is the concept behind this? Means in addition or subtraction, the final number or the final value will be adjusted till the numbers with least decimal digits. Clear? So that only they given. The resultant of addition or subtraction, the given number having different precisions. Precisions means, yesterday I already told you, if a number is having more number of decimal digits, that is having the more precision, right? If a number is having more number of decimal digits, దానికి ఎక్కువ ప్రిసిషన్ ఉంటుందమ్మా. క్లియర్? ఫర్ సపోజ్ వర్నియర్ క్యాలిపర్స్ ఈస్ హ్యావింగ్ మోర్ ప్రిసిషన్ ఆర్ ఆర్డినరీ స్కేల్ ఈస్ హ్యావింగ్ మోర్ ప్రిసిషన్? వర్నియర్ క్యాలిపర్స్, బికాస్ వర్నియర్ క్యాలిపర్స్లో లీస్ట్ కౌంట్ ఎంతమ్మా? 0.01 సెంటీమీటర్. క్లియర్? 0.01 సెంటీమీటర్. ఓకేనా? ఇప్పుడు ఆర్డినరీ స్కేల్ తీసుకుంటే ఆర్డినరీ స్కేల్లో లీస్ట్ కౌంట్ ఎంత? 0.1 సెంటీమీటర్. కరెక్టా? సో ఆర్డినరీ స్కేల్ లీస్ట్ కౌంట్ ఈస్ హౌ మచ్? 0.1 సెంటీమీటర్. Did you understand? Now which is having more precision? Vernier calipers. So precision లో మనకి ఎక్కువ నెంబర్ ఆఫ్ డెసిమల్ డిజిట్స్ వచ్చే అవకాశం ఉంటుందన్నమాట. సో వాట్ దే గివెన్, ద రిజల్టెంట్ ఆఫ్ అడిషన్ ఆర్ సబ్ట్రాక్షన్ ఇన్ ద గివెన్ నెంబర్ హ్యావింగ్ precision should be reported to the same number of decimal places as present in the number having least number of decimal places. Okay, which is having the least number of decimal places, the final answer should be reported with least number of decimal places. Are you clear up to here? Just write down that statement, because for NEET level statement based questions will also be appears. After that, take down these examples and tell me the final answers. Okay, take down these examples and tell me the answers. Just 3 examples I written here. The T examples values you tell me. Final answers. So if you see the pattern, like re-NEET and before NEET exam also, based on significant numbers one question came. You see na? In re-NEET also one question came. In before re-NEET exam also we have, actual NEET exam also one question came. So rounding off digits on that, for re-NEET and re-NEET we have one question. And if you see the re-NEET exam, in re-NEET exam from units and dimensions 3 questions came. Doing it, what is the first one answer? Yeah, final answer you telling or yeah, if you add all these things, what is the answer we are getting? 36.723. Now up to how many decimal digits we have to modify? We have to take up to how many decimals? 1 decimal, right? So if you take up to 1 decimal, because in the given data it is having the least number of least number of digits, right? Least number of decimal places. Okay, least number of decimal places. So our final answer should be reported with same least number of decimal digits. So last digit is 3, which is equal to less than 5. Less than 5 ante cut down the last digit, previous number no change. So answer is 36.72. Can we have to adjust or report it up to 1 decimal digit. Again take the last digit. Last digit is less than 5. Less than 5 means cut down the last digit. Are you clear? Previous number no change. 36.7 is the answer. Is it done? Yeah, next question, what is the answer? If you add all the values, what is the value you got? Tell me. 3.4722. Now up to how many decimal digits or decimal places we have to reduce? 2 decimal places. We have to report up to 2 decimal places. Now last digit is less than 5, right? So cut down the last digit. Previous number, no change. So then 3.472 is the value. Then last digit is 2. 2 is less than 5. So 2 is less than 5 means cut down the last digit. Previous number, no change. Then what is the value? 3.47. Then last number you do. How much you got the answer? Yeah, 38.28. Okay, fine. Tell me what is the actual answer? Yeah, after subtraction, 38.2818. Am I right? 38.2818. But who is having least decimal digits? This one. How many least decimal digits are there? 3. So we have to adjust our answer up to 3 decimal digits. Now last digit is 8, right? 8 is greater than 5. Greater than 5 means cut down the last digit. Previous number plus 1. Greater than 5 means preceding number plus 1. So then what is the answer? 38.282 is the answer. Clear? Preceding number plus 1 because last digit is greater than 5. Okay na? My last digit is greater than 5. So cut down the last digit and add plus 1 to the preceding number. Did you get it? Yeah. But then significant figures in multiplication and division. My multiplication and division, the final answer should be reported such that in the given data who is having the least significant numbers. Okay, in addition or subtraction we taken decimal places, avuna? Right? So in addition or subtraction we taken decimal places. కానీ multiplication or division we have to consider what? We have to consider what? Significant numbers. The significant numbers, least precision term in the calculation. Least significant numbers తీసుకోవాలి. Okay, now see, first number you see, 142.06. How many significant numbers are there here? 5. Are you clear? And the 0 trapped 0 kada, so we have to count. So total 1, 2, 3, 4, 5. So 5 significant numbers are there. In this, how many significant numbers are there? 2 significant numbers. So the final answer should be adjusted such that the final answer must be reported with least significant numbers. Okay na? So multiply cheyandi. What is the value? You just tell me. How much? బట్ ఇంకా చేయాలిగా. How much you got? Modify చేయి. How much you got first answer? తప్పు కదా. డెసిమల్ పాయింట్స్ పెట్టలా. ఫోర్ డెసిమల్ డిజిట్సా? 32 పాయింట్ వస్తుంది చూడమ్మా. క్యాలిక్యులేషన్ సరిగ్గా చేయండి. వీడు చేసింది కరెక్టే అనుకోండి. చూడు చేయి. సిగ్నిఫికెంట్ ఫిగర్స్కి రౌండ్ ఆఫ్ చేయి. ఎన్ని సిగ్నిఫికెంట్ ఫిగర్స్ ఉన్నాయి ఫస్ట్ దాంట్లో? First one, how much you got? 33, yeah? Very good. Yeah. What is the first one? Multiplication you did, right? What is the value you got? Tell me. 32 point. So 32.67. 38. Yeah. Now what we have to do? The final answer, the answer to the multiplication or division is round off to the same number of significant figures is possessed by the least precision term. అంటే ఫైనల్ ఆన్సర్ని ఎన్ని సిగ్నిఫికెంట్ ఫిగర్స్ వరకు మార్చాలమ్మా? 3 significant figures. Sorry, 2 significant figures. Okay, round off till 2 significant figures because it doesn't matter about the decimal digits here. Are you clear? We have to take what? Significant numbers. So therefore last digit is 8, right? 8 is what? Greater than 5. Then cut down the last digit, previous number plus 1. So therefore 32.674. Are you clear? Now last digit less than 4, less than 5. So cut down the last digit, previous number no change. So 32.67. Are you clear? Then final answer, how to do? How to take the final answer then? See, last digit is what? Greater than 5. Greater than 5 means previous number plus 1. That is 32.7. Then last digit is 7. Greater than 5. Then previous number plus 1. Approximately how much? 33. In the same way, do the next problem. Because here we have to take the least significant numbers. So they told that only, right? The answer to multiplication or division is round off the same number of significant figures is as possessed by the least precise term. Are you clear? Least precise term. So enta avutundamma answer 33. What should be this value? Then calculate. How much you got? 66.8466. So 66.8466. No, tell me once again. 66.84668. Now see, we have to reduce till 3 significant numbers. So last digit is greater than 5. Cut down this previous number plus 1. So 66.8467. Last digit greater than 5. So cut down the last digit. Previous number plus 1. So 66.847. Last digit greater than 5. Cut down the last digit. Previous number plus 1. So 66.85. Last digit greater than 5. Sorry, equal to 5. And preceding number even. 8 and even kada. Preceding number is even. So last digit equal to 5, preceding number even. Cut down the last digit, previous number no change. 66.8 is the answer. Are you clear? Got it? Now shall we go for the next example? Yeah. Order of magnitude. This is one more important thing. Must see. Generally in scientific notation, we can represent A into, just now I told you, A into 10 power B, right? Where B may be of any number. But scientific calculation law or scientific dantlo, how to modify this order of magnitude we are going to discuss. See, for suppose, 1 minute. For suppose, in scientific notation we can represent like this. Any value can be represented like A into 10 to the power of B. B may be of any number. And we have to take the significant numbers for only A, right? We have to take the significant digits for only A. Now for suppose, ఇప్పుడు మనకు ఒక వాల్యూ ఉంది 3 into 10 to the power of 8. This can be approximately written as 10 to the power of 8 in the scientific notation. Why? Because means here 3 is there, right? This 3 is what, less than 5. If 3 is less than 5, if this value is less than 5, here we have A into 10 to the power of B we discussed, right? For suppose if this A value is less than 5, if A value is less than 5, then you can write the final answer as approximately 10 to the power of B. Approximately how much you can write? 10 to the power of B. Gudpetkondamma. Are you clear? So see here, in 3 into 10 to the power of 8, this 3 is there, right? 3 is less than 5. So therefore this can be approximately taken as what? 10 to the power of 8. Now similarly, mass of electron they given. What is the mass of electron they given means? 9.1 into 10 to the power of minus 31 kg. Are you clear? Now if 9.1 into 10 to the power of 31 kg, here last digit is there, right? I mean this number is there, right? 9.1. This 9.1 is what? Greater than 5. Are you clear? Greater than 5. So therefore, if last digit is 5 or more than 5, then preceding digit is increased by 1. Are you clear? Preceding digit is what? Increased by 1. So appudu em cheyali ante this is increased by plus 1 means, okay, minus 31 plus 1. How much it is? Minus 30. Then this is approximately becomes how much? Minus 30. This is the order of magnitude. Are you clear? So please remember, in scientific notation, if a number is expressed as m into 10 to the power of x, that only I wrote it as a into 10 to the power of b. This is a scientific notation. Now for suppose m lies between where to where? 1 to 10. Okay, we have to take this m value between where to where? 1 to 10 only. For suppose sometimes when you are doing the calculation you got 0.2 into 10 to the power of 5 you got. Then how you have to modify this as 2 into 10 to the power of 4, because this value will be there, right? This should lies between where to where? 1 to 10. Are you clear? It should be integer and x should be a integer. Here b should be what? Integer. So instead of this you follow this notation only, no problem. For suppose if I take m to 10 to the power of x, this x may be of any integer. Integer means we may get positive values or we may get negative values also, including 0 also. We may get positive values, we may get negative values including 0. And m is between where to where? 1 to 10. M is taken between where to where? 1 to 10. So m should be taken between 1 to 10. Are you clear? And x may be of any number. It may be positive or it may be negative. అప్పుడు ఏం చేయాలమ్మా? For suppose the order of magnitude is 10 power required, 10 required to the present quantity. For this determining of power, to round off, what we have to do means, if the last digit is less than 5, if the last digit is less than 5, we have to ignore that number, and what is this value means, we have to write as it is 10 to the power of 8. If last digit is 5 or more than 5, are you clear? Then preceding number is there, this value should be increased by 1. This power value will be increased by 1. then 10 to the power of minus 31 plus 1, that is equal to 10 to the power of minus 30. Clear? Just write down this notation and write down these points. So how you will write means, in scientific notation how you can write m into 10 to the power of x. Are you clear? Order of magnitude. So m lies between where to where? 1 to 10. My m lies between where to where? 1 to 10. My here m lies between where to where? 1 to 10. And here x is there at, x is an integer, any integer. Okay? Just write down like a short points. For suppose if m is less than 5, then we have to ignore that value. Then this is approximately 10 to the power of x. What is there over? You have to write that same value. For suppose if m is greater than 5, then what we have to do? That is approximately 10 to the power of x plus 1. Now let us take 6.625 into 10 to the power of minus 34. Here 6.625 means greater than 5, right? Yeah, then how to write this magnitude as? How to write this magnitude as 10 to the power of minus 33. Remember. How to write that magnitude as 10 to the power of minus 33. Are you clear? Okay, now for suppose I'll take like this 1.6 into 10 to the power of minus 19. Yeah, it is less than 5, right? How to write the magnitude as? 10 to the power of minus 18 approximately. Are you clear? Approximately you have to write 10 to the power of minus 18. So we have to take this m digit. If m is greater than 5, are you clear? Add plus 1. Okay. If m is less than 5, you have to write as it is. This is the order of magnitude concept. Clear? 10 power? Yeah, 10 to the power of minus 19 plus 1, minus 18. Okay, less than 5, right? Sorry. It is less than 5, right? Yeah, I'm confused. So here what is the value? 1.6 into 10 to the power of minus 19. It is less than 5, right? So you can write approximately 10 to the power of minus 19. Okay. Then 6.67 into 10 to the power of minus 11. Do you remember all these values? ఇవన్నీ గుర్తున్నాయమ్మా. ఇది చార్జ్ ఆఫ్ ఎలక్ట్రాన్, ఇది ప్లాంక్స్ కాన్స్టెంట్, ఇది యూనివర్సల్ గ్రావిటేషన్ కాన్స్టెంట్. Then how to write this value? Yeah, approximately 10 power minus 10. Clear? Because 6.67 is greater than 5. Okay. Shall we go for the next topic? Yeah, the next topic is error. Okay, the next topic is what? My error. Yesterday we discussed about the concept of accuracy and precision. Do you remember? Okay na? దానికి ఒక ఎగ్జాంపుల్ కూడా చెప్తున్నాం, నాకు గుర్తుందా? ఫర్ సపోజ్ ఇఫ్ యూ టేక్ ఎ బుల్స్ ఐ, ఓకే, ఇఫ్ యూ టేక్ ఎ బుల్స్ ఐ, ఓకే, yeah, if you take a bull's eye and this is the target actually, now this is the target. If all the arrows are falling here, then what we can say? It is having more precision but less accuracy. More precision, less accuracy. For suppose if all the arrows are falling like this, are you clear? If all the arrows are falling like this, okay, so like this the arrows are falling and this is the arrow, one arrow which is close to the bullseye, remaining arrows are like this, then what we can say? More accurate but less precision. Clear? For suppose if I take it as a bullseye, now these are the arrows, clear, these are the arrows, then what we can say? Less accuracy and less precision. If all the arrows are falling here only, more accuracy and more precision. Are you clear? If any value is having more accuracy and more precision, then that value will have less error. Okay na? Adena ninna point మనం డిస్కస్ చేసుకుంది ఉన్నది అదే, we discussed, right? A value with more accuracy will have less error. Error should be less. Are you clear? Then what do you mean by error? Means the error is nothing but the deviation of the observed value from the standard value. Are you clear? understood, or the true value. Okay, so the deviation from the observed value from the true value, or mathematically we can say the difference between observed value as well as true value. అదే మనకి అదే ఇన్స్టాగ్రామ్ రీల్స్ దాంట్లో వస్తున్నాయి కదా, ఎక్స్పెక్టెడ్ వర్సెస్ రియాలిటీ, రైట్? ఎక్స్పెక్టెడ్ ఇస్ సంథింగ్, రియాలిటీ ఇస్ సంథింగ్. ఆర్ యూ క్లియర్? ద డిఫరెన్స్ ఉంది కదా, దాన్నే ఎర్రర్ అంటా ఉన్నాం. ఆర్ యూ క్లియర్? ఎక్స్పెక్టేషన్స్ వర్సెస్ రియాలిటీ. ఓకే, రియాలిటీలో మనకి ఏదో నెంబర్ ఉంది. ఫర్ సపోజ్ ఐ డిడ్ వన్ ఎక్స్పెరిమెంట్, యాక్సలరేషన్ డ్యూ టు గ్రావిటీ ఎక్స్పెరిమెంట్. ట్రూ వాల్యూ అంత 9.8 మీటర్/సెకండ్ స్క్వేర్. ఇది ట్రూ వాల్యూ. ఆర్ యూ క్లియర్? ఇది ఎక్స్పెక్టేషన్, అంత రావాలని ఎక్స్పెక్ట్ చేసి ప్రాక్టికల్ చేస్తాం అమ్మా. క్లియర్? బట్ వెన్ యూ ఆర్ డూయింగ్ ద ప్రాక్టికల్ దేర్ మే బీ సో మెనీ ఎర్రర్స్. బికాస్ ఆఫ్ దట్ ఎర్రర్స్ I got acceleration due to gravity as 5 only. So much of variation is there. This is nothing but error. Are you clear? Must see, in physics up to 10 to 15% errors are acceptable. Acceptable errors. 10% up to 10% errors or 15% errors are acceptable. అంతకన్నా ఎక్కువ వచ్చింది అంటే ఇంకా ప్రాక్టికల్ మనం తప్పు చేసినట్టే కంప్లీట్గా. ఆర్ యూ క్లియర్? బేసికలీ దెర్ మే బీ ఎర్రర్స్. ఇఫ్ యూ డూ ఎనీ వాల్యూ కంపల్సరీ ఎర్రర్స్ విల్ కమ్. Compulsory errors will come. Okay, na? Fine. Shall I move? Now see, for suppose g is equal to 9.8 is the true value, but when I did the experiment, okay, I got 9.3 only. Are you clear? Now the deviation from the standard value with the observed value, this is the observed value, experimental value, this is experimental value or observed value. The deviation from the observed value from the standard value, that is nothing but the error. And how to measure the error means the difference between the standard value and the observed value, that is nothing but what ma? Error. Are you clear? What do you mean by error? The deviation or the difference between standard value and the observed value, that is nothing but what? Error. Are you clear? So will you write that small definition like that? The deviation of standard value from the observed value or experimental value. The deviation from the standard value or the deviation in the between standard value and the observed value. This will use what ma? Error. Now types of errors, keep adding types of errors. But generally this type of errors we will not consider in NCERT. In NCERT, ఈ blunders systematic errors లో ఇచ్చేసాడు అమ్మ. Blunders మనకి systematic errors లో ఇచ్చేసాడు. Are you clear? Fine. So you just basically write two types of errors. First one is systematic errors and random errors. So errors, how many types we have? Systematic errors and random errors. Even blunders is also there. You can keep that in systematic errors only. We can write that blunders also in the systematic errors only. Systematic errors. Okay. Now what are systematic errors? Ante systematic errors are the unidirectional errors. These errors can be identified and it can be modified. Okay, systematic errors can be identified. You can identify the systematic errors and we can modify the errors also. Okay, na? Ma ippudu na watch lo time 4 minutes ekku undi, but actual time 10:13. So this error I can identify and I can modify also. This kind of errors comes under systematic errors. Are you clear? These are the unidirectional errors. Okay, my systematic errors aithe positive avachchu, even negative kuda avachchu. These systematic errors may be positive or may be negative also. Okay, so in the systematic error side you write down these errors are identifiable and can be fixed, ante manam modify cheyochu ani. Are you clear? These errors are identifiable as well as it can be fixed. Are you clear? This systematic errors, it can be positive or negative also. Systematic errors ani either it can be positive or it can be negative also. Okay na? అయితే సిస్టమాటిక్ ఎర్రర్స్ మనకి డిఫరెంట్ టైప్స్ ఆఫ్ ఎర్రర్స్ ఉంటాయి. ఆర్ యూ క్లియర్? మన సిస్టమాటిక్ ఎర్రర్స్ అగైన్ వీ హ్యావ్ ద డిఫరెంట్ టైప్స్ ఆఫ్ ఎర్రర్స్. ఇన్ దట్ ఫస్ట్ వన్ ఈస్ పర్సనల్ ఎర్రర్స్. ఆర్ యూ క్లియర్? పర్సనల్ ఎర్రర్స్, ఇప్పుడు బ్లండర్స్ ఉంది కదా, బ్లండర్స్ని మనం పర్సనల్ ఎర్రర్స్ కింద తీసేసుకోవచ్చు. మా సిస్టమాటిక్ ఎర్రర్స్ అగైన్ కన్సిస్ట్ ఆఫ్ డిఫరెంట్ టైప్స్ ఆఫ్ ఎర్రర్స్. పర్సనల్ ఎర్రర్స్, మా వాట్ ఈస్ అ పర్సనల్ ఎర్రర్స్ మీన్స్ ఫర్ సపోజ్ నాట్ డూయింగ్ ద ఎక్స్పెరిమెంట్ ప్రాపర్లీ. Okay, for suppose you are doing the experiment, somebody disturbed you, or you call somebody disturbed you. Now in simple pendulum experiment we have to take 20 oscillations and we have to count the time for 20 oscillations. మీరు ఎక్స్పెరిమెంట్ చేస్తున్నప్పుడు సడన్గా ఎవరో మీ ఫ్రెండ్ ఎవరో ఒక ఎరేజర్ పెన్సిల్ స్కేల్ అడిగారు, అలా తిరిగేసరికి ఇక్కడ 2 ఆసిలేషన్స్ అయిపోతాయి. మళ్ళీ ఈ ఎక్స్పెరిమెంట్ చేస్తే టైం ఎక్కువ పట్టేస్తుంది, మళ్ళీ ల్యాబ్లో వదలరేమో అని చెప్పి ఓకే నో ప్రాబ్లం కౌంట్ చేస్తాం. సో దీనివల్ల ఎర్రర్స్ వస్తాయి. So it can be taken as a personal error. Are you clear up to here? Or మీరు ఇలా కౌంట్ చేస్తున్నప్పుడు ఫర్ సపోజ్ వీ హ్యావ్ టు కౌంట్ ఫ్రమ్ వన్ ఎండ్ టు అనదర్ ఎండ్. అంటే ఇప్పుడు సింపుల్ పెండలం ఎక్స్పెరిమెంట్ మీరు చేస్తుంటే మన సింపుల్ పెండలం బాబ్ని ఒక ఎక్స్ట్రీమ్ పొజిషన్ తీసుకెళ్ళి వదులుతాం. వీ హ్యావ్ టు టేక్ ద ఆసిలేషన్ ఫ్రమ్ దిస్ ఎక్స్ట్రీమ్ పొజిషన్. అంటే ఈ ఎక్స్ట్రీమ్ పొజిషన్ నుంచి మళ్ళీ ఎక్స్ట్రీమ్ పొజిషన్కి వచ్చేసరికి ఒక ఆసిలేషన్ అవుతుంది. ఓకేనా? ఇప్పుడు మీరు సరిగ్గా అబ్జర్వ్ చేయలేదనుకో, వీ మే గెట్ సమ్ ఎర్రర్స్. These type of errors also comes under the systematic errors or personal errors. Or else sometimes when you are measuring the ammeter or voltmeter readings, we have to keep the eyes straight to the device. Chesara practicals, I think almost everyone did. Okay, fine. So we have to keep the head straight to the device. Sometimes we'll keep like this, I mean on the bench because I came across many students because when we are going to teach the chapter, for suppose any chapter is there, in that chapter if any experimental concepts are there, we'll teach the experiments along with that chapter. Okay, so when we are doing that kind of experiments, especially from the current electricity and all, most of my students what they will do, they will sit on the table like this and they will take the readings. So then the vision will be not parallax, that is called as parallax errors. Are you clear? That is called as parallax error because we have to always keep the head straight to the device. That's why they will keep one small mirror in ammeter or voltmeter, whatever the device are there, they will keep a small mirror. In that mirror you have to see to avoid the parallax errors. Okay, ఇప్పుడు ఫర్ సపోజ్ మనకు డివైస్ ఇలా ఉందనుకోమ్మా, ఇక్కడ చిన్న మిర్రర్ పెడతాడు ఇక్కడ. ఓకే, అండ్ ఇది రీడింగ్ పాయింటర్ అనుకో, మనం స్ట్రైట్గా చూసినప్పుడు ఆ మిర్రర్లో ఇమేజ్ మనకు కనబడకూడదు, స్ట్రైట్గా ఉండాలి. ఈ సైడ్కి పెడితే ఏమవుతుంది, మిర్రర్లో ఇక్కడ ఇమేజ్ కనబడుతుంది, అలా కనబడకూడదు. దోస్ ఆర్ కాల్డ్ as parallax errors. To avoid that parallax errors, they will keep a mirror. So those will also comes under the personal errors. Once again it comes under systematic errors. ఓకేనా? ఇప్పుడు నేను చిన్న వర్స్ట్ ఎగ్జాంపుల్ చెప్తాను, దాన్ని మీరు అదే మొన్న చెప్పిందే అదే కుక్ చేయడం అలాగా ఒక వర్స్ట్ ఎగ్జాంపుల్. మళ్ళీ లాస్ట్ టైం మా పాప ఎవరో గట్టిగా నవ్వేసింది, అదే ఎగ్జాంపుల్ మళ్ళీ నేను యూజ్ చేస్తాను. Okay, the second error is imperfections in the practical procedure. You have to follow one procedure while doing the practical. Okay na? For example, నేను ఒక ఎగ్ కర్రీ ప్రిపేర్ చేద్దాం అనుకుంటున్నాను. ఓకే, దానికి ఫస్ట్ మనం ఏం చేయాలంటే ఒక బౌల్ తీసుకొని దాంట్లో కొంచెం ఆయిల్ పోసి ఆమె తర్వాత కొంచెం ఆనియన్స్ టమాటోనో లేకపోతే పచ్చిమిర్చి అవన్నీ వేసి కొంచెంసేపు బాయిల్ చేసినాక కొంచెం సాల్ట్ పెప్పర్ ఆర్ ఎల్స్ దట్ కారం అన్నీ యాడ్ చేసి ఆ తర్వాత ఎగ్స్ పెట్టి వాటర్ పెట్టి కొంచెం బాయిల్ చేయాలి. సో దిస్ ఈజ్ ద ప్రొసీజర్, స్టెప్ టు స్టెప్ ప్రొసీజర్. ఎలాగ ఎగ్ కర్రీ ఏదో ప్రిపేర్ చేసేదని చెప్పి అన్నీ కట్ చేసేసి ఒక బౌల్లో వేసేసి వాటర్ పోసేసి కొంచెం ఆయిల్ పెట్టి బాయిల్ చేస్తాను అనుకో, అది ఎగ్ కర్రీ అవుదమ్మా. రైట్, అంటే ప్రొసీజర్ ఏం లేదు ఇక్కడ. రైట్, సో డోంట్ లాఫ్, జస్ట్ ఎగ్జాంపుల్, ఒక ఎగ్జాగరేషన్ అంతే, అర్థం చేసుకోవడానికి ఒక ఎగ్జాగరేషన్. అంటే ఒక ప్రొసీజర్ అంటూ ఉంటుంది, వీ హ్యావ్ టు ఫాలో దట్ ప్రొసీజర్. Okay, now when you are doing the practical, some students may be lack of interest or lack of experimental knowledge. Are you clear? Lack of interest or lack of experimental knowledge, some people will commit the errors. Okay, now there will be some experimental procedure to follow, so some students may not follow that experimental procedures. Are you clear? Because of that also we may get the errors. ఈ ఎర్రర్స్ మనం పర్సనల్ ఎర్రర్స్ కింద చెప్పుకోవచ్చు, ఈవెన్ ఇంపర్ఫెక్షన్స్ ఇన్ ద ప్రాక్టికల్ ప్రొసీజర్ అని కూడా చెప్పుకోవచ్చు. ఆర్ యూ క్లియర్? సో ఇన్ సిస్టమాటిక్ ఎర్రర్స్ వీ మే గెట్ అదే అబ్జర్వేషనల్ ఎర్రర్స్. ఆర్ యూ క్లియర్? వెన్ ద అబ్జర్వర్ డజంట్ రీడ్ ద మెజర్మెంట్స్ కరెక్ట్లీ. ఆర్ యూ క్లియర్? వెన్ ద అబ్జర్వేషన్స్ డజంట్ కరెక్ట్లీ, ఇఫ్ యూ డింట్ మెజర్, so then we may get the errors. Those errors are called as what? Systematic errors. Are you clear? So we can say, imperfections in the practical procedure. Clear? Imperfections in the practical procedure. Okay? Other theoretical procedure and kuda antam. See, when the experimental procedure is flawed, are you clear? Ante tappu unna experimental procedure tappu undi, or else the creating inaccuracies in the experiment. Ante మనకి ఎక్స్పెరిమెంట్లో తప్పులు ఉన్నప్పుడు మనం ప్రొసీజర్ కరెక్ట్గా చేయనప్పుడు మనకు ఖచ్చితంగా ఎర్రర్స్ వస్తాయి. ఆర్ యూ క్లియర్? దోస్ ఆర్ నథింగ్ బట్ థియరిటికల్ ఎర్రర్స్ ఆర్ imperfections in the experimental procedure. Are you clear? So imperfections in the experimental procedure. Clear? Imperfections in the experimental procedure. In systematic errors we may get personal errors, first type. Next, imperfections in the practical procedure, or that can be taken as theoretical procedures also. Okay, personal errors may comes under the observational errors. Are you clear? Personal errors may comes under the observational errors. What I am going to write here, you write this, no problem. Both are same only. Both are same only. You can write down even these points also. But sometimes, for suppose you understood the practical well, you are very brilliant student, you are doing practical in such a precise way, perfectly you are calculating, but your instrument is not good. Are you clear? You are very good student, you understood the practical procedure very well, and this time instrument is not good. Because of the defects in the instruments also, sometimes we'll get the errors. Those errors comes under which errors? Instrumental errors. Then third type of personal errors, systematic errors, is imperfections in the instrument. Are you clear? Imperfections in the instrument, or if you use the defected instrument, we will get the systematic errors. Okay, these are the major reasons to get the systematic errors. Okay, no? Then random errors. Random errors caused because of any reason. A particular reason will not be there. Okay, random errors may be of any reason. Now if you take random errors due to any reason, any reason I understand. Are you clear? And these random errors we can take it as either positive or negative. Clear? For suppose two students doing the experiment on the same device, are you clear? And they are following the experimental procedure perfectly, and they are doing absolutely zero personal errors. The two students are not doing any personal errors. They are doing perfect, and practical procedure also perfect way they are doing. And instrument is also very good, perfect instrument. But still, on the same apparatus, if two students are doing the practical, still they may get different values. Then reason ఏదైనా ఉండొచ్చు. Because for suppose when you are doing the experiment, maybe suddenly the temperature changed. The temperature effect may vary your experiment, may vary your values. Are you clear? మాకు కొన్ని ఎక్స్పెరిమెంట్స్కి మోస్ట్ సెన్సిటివ్ థింగ్స్ కావాలి, అంటే మోస్ట్ సెన్సిటివిటీగా ఉండాలి. ద బెస్ట్ ఎగ్జాంపుల్, రీసెంట్గా నేను ఏదో చదివాను న్యూస్ పేపర్లో, క్వాంటమ్ కంప్యూటర్ అంట. క్వాంటమ్ కంప్యూటర్, మాకు క్వాంటమ్ కంప్యూటర్ ఈజ్ సచ్ ఎ సెన్సిటివ్ డివైస్ దట్ ఈవెన్ ద వైబ్రేషన్స్ వెన్ యూ ఆర్ వాకింగ్, దట్ మే ఆల్సో ఎఫెక్ట్ ద వాల్యూస్ ఆఫ్ దట్ ఇన్స్ట్రుమెంట్. ఓకేనా? అంటే ఇప్పుడు ఫర్ సపోజ్ ఏదో క్వాంటమ్ కంప్యూటర్ ఇక్కడ ఉంది, నేను అదే రూమ్లోకి ఎంటర్ అవుతున్నప్పుడు ఈ వైబ్రేషన్స్ వస్తాయి కదా, ఈ వైబ్రేషన్స్ వల్ల కూడా వాల్యూ చేంజ్ అయిపోవచ్చు అంట. అంత సెన్సిటివ్ డివైస్ అంట క్వాంటమ్ కంప్యూటర్. రీసెంట్లీ ఐ స్టడీడ్ ఇన్ వన్ న్యూస్ పేపర్. ఓకే, సో అంటే ఇక్కడ రీజన్ ఏదైనా ఉండొచ్చు. నేను వాక్ చేయడం వల్ల వాల్యూ మారిపోయిందంట. చాలా కామెడీగా ఉంది వినడానికి, రైట్? బట్ ఓకే, ఇట్ మే బీ ఆఫ్ ఎనీ రీజన్. వాక్ చేయడం వల్ల వైబ్రేషన్స్ వల్ల వాల్యూ మారిపోతుందంట. So that's why the scientists who are working with the quantum computers, they are wearing a special suits and they are entering into that particular laboratory. Okay na? So fine. So random errors oka particular reason valla vastundi anedani cheppalemu. It may be of any reasons, because when you are doing the experiment, maybe the variation of the temperature or the variation of pressure or variation in the voltage fluctuations when you are doing with the current calculations or current experiments, current related experiments. నువ్వు కరెంట్ రిలేటెడ్ ఎక్స్పెరిమెంట్స్ చేస్తున్నప్పుడు సడన్గా వోల్టేజ్ ఫ్లక్చువేషన్స్ వచ్చాయి, దానివల్ల కూడా మనకు వాల్యూస్ చేంజ్ అయిపోవచ్చు. సో దట్స్ వై టూ బ్రిలియంట్ స్టూడెంట్స్ వర్కింగ్ ఆన్ ద సేమ్ ప్రాక్టికల్, డూయింగ్ ఇన్ ద సేమ్ పర్ఫెక్ట్ ప్రొసీజర్ ఆన్ ద సేమ్ ఇన్స్ట్రుమెంట్ మే గెట్ టూ డిఫరెంట్ వాల్యూస్ బికాస్ ఆఫ్ ద అట్మాస్ఫిరిక్ ఎఫెక్ట్స్ ఆర్ ఎనీథింగ్ ఎల్స్. క్లియర్? సో ర్యాండమ్ ఎర్రర్స్ మే బీ ఆఫ్ ఎనీ రీజన్. Are you clear? So you just write down, it may be of any reasons, okay? It may be of any reasons. And random errors, you can take it as positive, even you can take it as what, negative also, okay? Yeah, the next one is least count errors. The next one is least count errors. Least count errors. The least count of any device can also be taken as an error. Are you clear? The least count of any device can also be taken as what, error. For suppose if you take ordinary scale, in ordinary scale, what is the least count? Tell me what is the least count in ordinary scale? 0.1 centimeter. This can be taken as an error. Are you clear? The least count of a device can be taken as what, an error. Are you clear? So that can be taken as what, 0.1 centimeter. For suppose if you take vernier scale, in vernier scale, what is the least count? 0.01 centimeter. So that 0.01 can also be taken as what, error. Are you clear? So the least count of a instrument can be taken as what? Error. That error is called as which error? Least count error. So write down that point. The least count of a device can be taken as an error. Is it done? Yeah, right done. For scale, least count is how much? 0.1. So that is only taken as error. Fine. Next, you write down 0 errors. Now, for suppose sometimes if you take in screw gauge or vernier calipers, the pointers may not exactly coincide with each other. Okay, sometimes it may be above or it may be below. Then what we have to do means we have to add the 0 error correction. Are you clear? అంటే ఏం లేదమ్మా, ఫర్ సపోజ్ ఎర్రర్ ఎక్కువ వచ్చిందనుకో దాన్ని జీరో చేయడానికి నెగిటివ్ యాడ్ చేయాలి. ఎర్రర్ తక్కువ వచ్చిందనుకో, బిలో వాల్యూ వచ్చిందనుకో, దాన్ని మళ్ళీ అగైన్ జీరోకి అడ్జస్ట్ చేయడానికి అగైన్ వీ హ్యావ్ టు టేక్ ద పాజిటివ్ ఎర్రర్. సో ఫైనలీ టు గెట్ ద జీరో ఎర్రర్, సో టు గెట్ జీరో ఎర్రర్ ఆర్ నల్లిఫైడ్ ఎర్రర్. ఆర్ యూ క్లియర్? అండర్స్టూడ్ మా. ఫర్ సపోజ్ ఇన్ కేస్ ఇఫ్ యూ గెట్ పాజిటివ్ ఎర్రర్ వీ హ్యావ్ టు టేక్ కరెక్షన్ యాజ్ వాట్ మా, నెగిటివ్ టు గెట్ ద జీరో ఎర్రర్. దీన్ని మనం బాగా అర్థం చేసుకోవాలంటే ఒక చిన్న ఎగ్జాంపుల్, మన వాచ్ ఒక ఎగ్జాంపుల్. ఇప్పుడు ఎగ్జాక్ట్లీ టైమ్ నిజం చెప్పాలంటే టైం ఎంత అయిందంటే 12:45 అయింది. బట్ ఇన్ మై వాచ్ ఇట్ ఈస్ 12:54, సారీ 12:44, అంటే 4 minutes ఎక్స్ట్రా. దట్స్ 4 minutes ఎక్స్ట్రా వీ కెన్ నల్లిఫై. దెన్ వాట్ వీ కెన్ డూ, జస్ట్ ప్రెస్ ద బటన్, సో అడ్జస్ట్ టు 12:45. క్లియర్? అడ్జస్ట్ టు 12:45. సో జీరో ఎర్రర్ కెన్ బి అడ్జస్టెడ్. సో జీరో ఎర్రర్ కెన్ బి వాట్ మా, అడ్జస్టెడ్. ఐ గాట్ పాజిటివ్ వాల్యూ, correction what I did, negative. For suppose if my watch is 4 minutes slow, I can adjust the value to 4 minutes fast. So we can adjust the zero error. Okay na? Now for suppose if you go for any grocery shop and all or vegetable market and all, you know nowadays we have the digital weighing machine. On the digital weighing machine, if they remove that bucket or basket, whatever it may be, initially it is showing some 100, -100. Then what they will do, you know, they will keep that particular device or bucket or whatever that measuring instrument are there, అది దాని మీద పెట్టి ఏం చేస్తారంటే ఎక్కువైనా తక్కువైనా ఒక జీరో బటన్ నొక్కుతారు. అబ్జర్వ్ చేస్తారేమో, అప్పుడు కంప్లీట్గా బ్యాలెన్స్ ఏమవుతుందంటే జీరో చూపిస్తుంది. ఇప్పుడు ఇన్ దట్ విల్ యాడ్ ద గ్రాసరీస్. అర్థమవుతుందా? అబ్జర్వ్ చేశారు అది ఏదైనా మార్కెట్కి వెళ్ళినప్పుడు. ఇది ఒక మెజరింగ్ ఇన్స్ట్రుమెంట్ ఉంటుంది కదా, సో ఒక డిజిటల్ ప్యానల్ తోటి. So sometimes if you remove that, I mean whatever the ఈ bucket or I mean this basket, if you remove, ఇక్కడ మనకి నెగిటివ్లో చూపిస్తున్నాము. ఓకేనా. ఇక్కడ ఒక బటన్ ఉంటుంది, రీసెట్ బటన్, సంథింగ్ లైక్ దట్. ఇఫ్ యూ ప్రెస్ దట్ బటన్ ఇట్ విల్ షో 0. ఇట్ విల్ షో 0 అంటే ఇప్పుడు ఎర్రర్ ఎంత చేస్తామో 0 చేస్తాం. సో దట్ 0 error can be adjusted. Are you clear? So if error is positive we have to subtract. If error is negative we have to add to make it as 0. Are you clear? So that point you just write down. If error is positive, the correction should be what? Negative. And if error is negative, then correction should be what? Positive. Okay, we can say that 0 error can be what? Adjusted. Okay, we can say that 0 error can be adjusted. మరి ఏదైనా ఒక ఇన్స్ట్రుమెంట్లో 0 ఎర్రర్ని మనం అడ్జస్ట్ చేయొచ్చు, బట్ ప్రిసిషన్ వీ కెనాట్ అడ్జస్ట్. ప్లీజ్ రిమెంబర్, వీ కెనాట్ అడ్జస్ట్ ద ప్రిసిషన్. ఓకే, వీ కెన్ అడ్జస్ట్ ద ఎర్రర్, వీ కెనాట్ అడ్జస్ట్ ద ప్రిసిషన్ బికాస్ precision gives the least count of the device. We already studied yesterday concept only, we studied least count of a device will gives what ma precision. ఆ డివైస్కి లీస్ట్ కౌంట్ని మనం మార్చలేం, అది డిజైనింగ్ తోటే వస్తుంది, బట్ 0 ఎర్రర్ని మనం మార్చచ్చు. ఆర్ యూ క్లియర్? మరి దానికి అర్థం చేసుకోవడానికి చిన్న ఎగ్జాంపుల్ చెప్తాను. ఫర్ సపోజ్ ఐ విల్ టేక్ 2 different watches, clock A and clock B. Clear? I will take a clock A and I will take clock B. Clear? I will take clock A and clock B. Now we are measuring the time of clock A and clock B every day 12:45. Every day 12:45 I am measuring the times of clock A and clock B. రెండు క్లాక్స్ ఇక్కడ పెట్టాను, ఆ రెండు క్లాక్స్ టైమ్స్ ఇలా షో చేస్తున్నాను. ఓకే, 12:45కి నేను మెజర్ చేద్దాం అనుకుంటున్నాను. ఆర్ యూ క్లియర్? ఐ వాంట్ టు మెజర్ అట్ 12:45. ఆర్ యూ క్లియర్? నౌ సీ, for suppose first clock is showing the time like 10:45. Are you clear? 10:45, some 54 minutes or something seconds, something it is showing. Are you clear? Now second day, on second day it is showing 11:30, 52 seconds. Are you clear? Now 11:30, 52 seconds. Or third day it is showing 12:45, 56 seconds. Or else I will take like this 32 seconds, and here I will take 52 some value 19 seconds, and next day it is showing 9:30, 15 seconds. Are you clear? Okay, so EV values of clock A. Now this is the values of clock A. Are you clear? Now clock B, you see, clock B. In clock B it is showing like this. For suppose 11:59. Are you clear? It is showing 11:59 and only just one decimal digit is showing. It is only showing one decimal digit, or else 1 second, something like that, or exactly 11:59 it is showing, 11 hours 59. Next it is showing like 12. For suppose 11:59 I take, I'll take like this 12:44. Okay, 12:44, 1 second. Okay, 12:44, 1 second. And next one 12:43, 3 seconds or 2 seconds, and 12:44, 5 seconds it is showing. Now 12:46, 7 seconds it is showing. Clear? Now tell me which clock is better to design, clock A or clock B? Which is more better clock to design, clock A or clock B? మా క్లాక్ ఏలో ఎర్రర్ ఎక్కువ ఉందమ్మా, క్లాక్ బీలో ఎర్రర్ తక్కువ ఉంది, బట్ ఇన్ క్లాక్ ఏ వీ హ్యావ్ మోర్ ప్రిసిషన్. ఓకే, ఇన్ క్లాక్ బీ వీ హ్యావ్ లెస్ ప్రిసిషన్. ప్రిసిషన్ కెనాట్ బి చేంజ్డ్, ప్రిసిషన్ కెనాట్ బి చేంజ్డ్, బట్ 0 ఎర్రర్ కెన్ బి అడ్జస్టెడ్. మరి ఇక్కడ 0 ఎర్రర్ వచ్చినా పర్వాలేదు, దాన్ని అడ్జస్ట్ చేసుకోవచ్చు, వీ కెన్ అడ్జస్ట్ ద టైమ్. బట్ ప్రిసిషన్ ఉంది కదా, ఇట్ ఈస్ హ్యావింగ్ మోర్ ప్రిసిషన్ దాన్ ద సెకండ్ క్లాక్. First clock is having more precision than the second clock. Did you understand this point? My first clock is having more precision than the second clock. So therefore we can use the clock A to design the a clock, a perfect clock. It can be used as a perfect clock. ఎందుకంటే ఈ ఎర్రర్స్ ఉన్నాయి కదా, ఈ ఎర్రర్స్ కెన్ బి అడ్జస్టెడ్ బట్ ప్రిసిషన్ కెనాట్ బి అడ్జస్టెడ్. సో క్లాక్ A is having more precision than the clock B. Are you clear? Yeah, fine. So then we'll go for the next topic, that is errors in the measurements. Errors in the measurements. In that first you write down true value or mean value. Yeah, what do you mean by true value and mean value? Means, for suppose if I take A1, A2, A3, A4 and so on, AN are the readings. All these are what? My readings. Are you clear? All these are what? Readings. A1, A2, A3 and so on, AN are the readings. Then how to measure the true value or mean value? Means the true value or mean value can be taken as average of all the numbers. The average of all the values will give the true value. Okay, now please remember, if you take more readings, then error will be less. Okay, now ఎక్కువ readings తీసుకుని average చేసుకుంటే this value will be close to true value. Are you clear? Now if you take mean of all the readings, that value will be close to which value? True value. So for suppose అందుకే మనం సింపుల్ పెండ్లం ఎక్స్పెరిమెంట్ చేసినప్పుడు మేబీ 5 or 6 ట్రయల్స్ తీసుకుంటాం, అండ్ అగైన్ ఇన్ ఈచ్ ట్రయల్ అగైన్ 3 ట్రయల్స్ తీసుకుంటాం. ట్రయల్ 1, ట్రయల్ 2, ట్రయల్ 3, L2, ట్రయల్ 1, ట్రయల్ 2, ట్రయల్ 3, and 40 centimeters ki trial 1, trial 2, trial 3. So if you take number of readings, more number of readings, the average of that value will be very much close to where? True value. So if you take more number of readings, the average of all the readings will be close to where? True value. Are you clear? So just write down first one, true value or mean value. If A1, A2, A3 and so on, AN are the readings. If A1, A2, A3 and so on, AN are the readings. Then true values or mean values, just write down that mean value, A mean or A true. Even we can call it as A true, because okay. Then next one, absolute error. Now what do you mean by absolute error? Means, for suppose if you take average of all the values, you get true value, right? Now let us take acceleration due to gravity true value is 9.8, I will. First I did the experiment, in the first trial I got 9.6, and in the second trial I got it as, let us say, 9.9. In the third trial I got it as 9.5. In fourth trial I got it as 10. Some 4 trials I taken. Are you clear? Now what do you mean by absolute error? Means the difference between the true value and a particular reading. Are you clear? The difference between true value and a particular reading. Okay, now for suppose first I'll take the difference between these two values. Now tell me what is the difference between these two values. 9.8 minus 9.6, that value will be 0.2. Now for suppose I'll take the difference between the second value and the true value. The difference between second value and true value is how much? Tell me. 9.8 minus 9.9, what is that value? Minus 0.1. No, minus 0.1. And similarly, the difference between the third reading and fourth reading, 9.8 minus 9.5, what is this value? 0.3. Next, 9.8 minus 9.6, sorry, 10 I taken. So that is how much? Minus 0.2. Are you clear? Now what do you mean by absolute error? Means it is a difference between the observed value as well as the true value. But difference between whom and whom? Observed value and the true value. But sometimes we may get positive value, sometimes we get negative value, right? To avoid that, take the magnitude. Clear? Take what? Magnitude. Are you clear? Then it should be always positive. Even though negative value also we can convert it as positive. Are you clear? So mean absolute error is always absolute error is always what? Positive. Clear? So just write down. It is a difference between true value and the observed value or measured value. It is a difference between whom and whom? Difference between true value and measured value. Okay, second point, absolute error is always positive. We have to take always absolute error as positive. Absolute error is always positive. కానీ sometimes we are getting negative answer కదా, so that's why what we have to keep the modulus. Right, so then you write down this is the absolute error in the first reading, right? First reading la absolute error amma ide. This is what absolute error in second reading. Like that, this is what absolute error in the nth reading. My absolute error in which reading? Ma nth reading. So just write down. So this is absolute error in which reading? First measurement or first reading. Absolute error in first reading. Okay, and this is what absolute error in second reading. And so on. This is the absolute error in nth reading. In nth reading, what is the absolute error? Means am minus an, where am is a true value or mean value. My am ante entamma true value or mean value. Okay, the next one, mean absolute error. Next one is mean absolute error. Mean absolute error. Now what is mean absolute error? Means it is the mean of all the absolute errors, arithmetic mean of all the absolute errors. So just note it down. For suppose just now we calculated the absolute mean, right? My delta a1 can be taken as a true value, or even you can write it as a mean value minus first reading, correct? And delta a2 ఎంత అవుతుందమ్మా? delta a2 is equal to a true value minus a2. Am I right? Now delta a3 ఎంత అవుతుందమ్మా? delta a3 ఎంత అవుతుంది? a true value minus a3. ఇదే విధంగా delta an, what is delta an value? a true value minus an అవుతుంది, అవునా? ఇప్పుడు ఈ ప్రతి absolute error కి మీన్ తీసుకోండి. So that is delta a1 plus delta a2 plus and so on delta an by n. This is nothing but arithmetic mean of absolute errors. Are you clear? Arithmetic mean of whom? Absolute errors. That is called as which error? Mean absolute error. And it is defined with formula delta a mean. Kinda mean and write delta a mean. Are you clear? That is equal to magnitude of delta a1 plus magnitude of delta a2 plus and so on delta an by n. Now this is delta a mean. Okay, just write down delta a mean. This is mean absolute error, or you can write it as bar also. Instead of delta a mean, you can write a bar also, delta a bar also. Okay, na a bar and kuda write delta a bar. Okay, delta a bar, or even you can represent like this also, delta a mean. Okay. Then next one, relative error or fractional error. My relative error, fractional error means relative means comparison. Please remember. My relativity means what? Ma comparison. Try to understand. What do you mean by relativity? Ma comparison. Relative means what? Comparison. So what is relative error? Means comparison. It is the comparison between mean absolute error and the true value or mean value. Are you clear? Ma it is a comparison between whom and whom? Mean absolute error and mean value or true value. Are you clear? So relative error or fractional error can be taken as delta a mean divided by a mean, or this is also having one more name, a true value, because mean value is very close to true value. Okay, na? Just write down that formula. Relative error is equal to delta a mean by a mean. So mean absolute error by mean value. Then in percentage error, what we have to do? Multiply this with 100%. Are you clear? So percentage error is nothing but relative error multiplied by 100%. My relative error multiplied by 100%. That is nothing but percentage error. Got it? So what is relative error? Means relative error is once again delta a mean divided by a mean or a true value into 100%. So this is percentage error. Okay. then keep the heading combination of errors. Combination of errors. Combination of errors. In combination of errors, the first combination is addition or subtraction. Okay, directly I'll explain addition or subtraction. Must see, for every value there may be some error attached to it. There may be some error because of any reason. Reasons చెప్పుకున్నాం కదా, it may be of instrumental errors, or it may be of random errors, or it may be instrumental errors, or it may be least count errors, or systematic errors. We may expect some error along with the true value. Are you clear? We may expect error along with the true value. Are you clear? Okay na? Now for suppose I will take a as one number. I will take a as one number. That number I will take it as a plus or minus delta a. This is one number. Here delta a is there. That delta a is nothing but error. Okay na? But the delta a is nothing but what ma? Error. And a is the number. A is a number. And similarly one more number I will take b. That b is equal to b plus or minus delta b. Now what is delta b? Error in value of b. What is delta a? Error in value of a. Are you clear? Understood this point? Then if you add these two or if you subtract these two, we have to take number along with error. Okay na? Now for suppose మనకి ఏదో ఒక వాల్యూ ఉందమ్మా, ఏ ఉంది బి ఉంది, యాడ్ చేయమన్నాం అనుకో, ఏ ప్లస్ బి చేసేస్తాం, అయిపోయింది, సింపుల్. But we have error in the a. I will take it as z. Let us suppose I will take it as z. Adding of the final value, you will get z. ఓకేనా? యాక్చువల్లీ ఏ ప్లస్ బి అంటే ఒక వాల్యూ వస్తుంది కదా, ఆ వాల్యూని ఏదో నెంబర్తో తీసుకున్నాం, దట్ నెంబర్ ఈజ్ వాట్ మా z. ఎనీ నెంబర్ వీ కెన్ టేక్. ఆర్ యూ క్లియర్ అప్ టు హియర్? బట్ ఇఫ్ యు ఆర్ యాడింగ్ విత్ ఎర్రర్, ఇఫ్ యు ఆర్ యాడింగ్ విత్ ఎర్రర్, then to the final answer we have to add the error also. But to the final answer we have to add what ma? Error also. Then for addition or subtraction, I will take either addition or subtraction. Are you clear? For addition or subtraction we have to take z plus or minus delta z. మా a ప్లస్ బిని డైరెక్ట్గా యాడ్ చేస్తే z వస్తుంది, అంతే, అయిపోయింది. బట్ ఇక్కడ ఎర్రర్స్ ఉన్నాయి కదా, ఈ ఎర్రర్స్ వల్ల ఫైనల్ ఆన్సర్లో కూడా ఎర్రర్ వస్తుందమ్మా. దట్ ఎర్రర్ ఈజ్ నథింగ్ బట్ వాట్? డెల్టా z. ఆర్ యూ క్లియర్? Understood this point? Now please try to understand in addition. If I take error in addition, I will take error in addition. In addition z plus or minus delta z ఉంది కదా, దీన్ని ఎలా రాయాలి అంటే, for suppose first I will take z value. First I will take z value. Z you can write it as a plus b. So directly add a plus b. ఇదేనా ఫైనల్ ఆన్సర్? ఫైనల్ ఆన్సర్ is what? Final answer is z plus or minus delta z. Are you clear? Now for suppose I given 10, I given 20. So 10 plus 20 is equal to how much? 30. So z equal to 30. Easy only. But I given 10 plus or minus 0.1, 20 plus or minus 0.2. Then final answer you have to write 30 plus or minus error also you have to write. Are you clear? So here also we have to add the error. That error I will take it as what? Delta z. మరి చూడండి, ఇప్పుడు z ని ఏమని రాయొచ్చు అంటే డైరెక్ట్లీ a plus b అని రాయండి. So in addition, delta z can be taken as plus or minus delta a plus delta b. Clear? ఇప్పుడు క్లాస్ ఉందా నెక్స్ట్? just can you wait for fun? Okay, fine. So in addition, z equal to a plus b, and what is the error? Plus or minus delta a plus delta b. This is the error in addition. Okay, so in error in addition we have to take addition of both the errors and add it to the final answer. Then final answer will be how much? Z plus or minus delta z. Then in case of subtraction, in case of subtraction, z can be taken as a minus b. These values we have to subtract. Are you clear? And what should be the error? Means error value is once again same, that is delta a plus delta b. Clear? Again the error should be same. What is that value? Delta a plus delta b. Okay, so then final answer, this z plus or minus delta z. Shall I give some 2 questions based on this? Okay, so write down first these 2. So in addition or subtraction, error value will be same. Please remember, in addition or subtraction, error value will be same. Yeah, in addition or subtraction, error value is same. What is that error value? Delta z equal to plus or minus delta a plus delta b. Okay, but in addition you will get small a plus small b. In subtraction you will get small a minus small b. Are you clear? Shall I give the question? Is it done? Yeah. One example I will give. Write down one example. Now for suppose resistance R1 is equal to 10 plus or minus 0.1 ohm and resistance R2 is equal to, let us say, 30 plus or minus 0.3 ohm. Okay, they are connected in series. But they are connected in series. Then what is the error in resistance? Connected in Verma series. Okay, they are connected in series. Okay, they are connected in where? Series. Okay, what is the effective resistance of the combination? Okay, my series ante even rayali R series is equal to R1 plus R2. Am I right? My R series is equal to how much? R1 plus R2. So therefore, we have to take error in addition. Correct? We have to take error in where? Addition. Are you clear? Then take it as A, take it as delta A. Take it as B, take it as delta B. Now how to write first? Z is equal to A plus B kada? A plus B ante enta avutundamma? 10 plus 30, that is equal to 40. Then how to write delta Z? Delta Z ante error kada? So that is plus or minus delta A plus delta B. What is delta A? Plus or minus delta A value 0.1 plus 0.3. What is value? 0.4. Then final answer. What is the final answer? 40 plus or minus 0.4. So final answer means Z plus or minus delta Z, right? So that is 40 plus or minus 0.4. Now here what we have to do means addition you do. Z equal to A plus B. Delta Z error value plus or minus delta A plus delta B. Add the error separately. Then final answer you keep both. This is one example in error in addition. Okay. Then next, I'll give you one more problem. For suppose the temperature in the morning is 27 plus or minus 0.5 degrees centigrade. Are you clear? Let us take now the temperature is, now what is the temperature now means 39 plus or minus 0.3 degrees centigrade. Are you clear? Okay, fine, here I'll write. So T1 is equal to, now the temperature is 27 plus or minus 0.5 degrees centigrade. And at present temperature is, let us say, how much I taken? 39 plus or minus 0.3 degrees centigrade. Now what is the rise in temperature? This is the question. What is the rise in temperature? Rise in temperature ante em cheyochu? Subtraction. Right? Rise in temperature. Ante ekku perigindi, enta taggindi. So for that we have to take subtraction or difference. Okay? So ante take delta T is equal to T2 minus T1, which means that it is a subtraction. Then do it. Is it done? What is the answer? Ma, what is the answer? Yeah, tell me what is the answer? Yeah, so Z is equal to A minus B kada? So A minus B or B minus A you take because T2 minus T1, right? So B minus A. What is B minus A? 39 minus. Ma, 39 minus. What is that value? 27. So this value will be 12. And delta Z if you take plus or minus delta A plus delta B. Because in addition or subtraction, error should be always added. Right, ma? In addition or subtraction, always the error should be added. Are you clear? Error add cheyalsinde. Here you cannot take delta A minus delta B. Error should be always added. Only the numerical values we have to subtract. So అంటే ఇప్పుడు ఇది ఎంత అవుతుంది 0.5 plus 0.3 plus or minus, that will be 0.8. Are you clear? Then z plus or minus delta z is equal to 12 plus or minus 0.8 is the answer. Are you clear up to here? Yeah.